Can you explain maybe next slide? Ah, yeah. Previous.
The user participation? You mean this one?
Yeah, here there are some.
The cheating detection you were mentioning on the previous one?
Ah, yeah.
Yes, cheating detection. Actually, cheating detection means that we discover that this task or the output delivered task is not accurate or not correct. And we make cheating detection by many techniques. For example, either normal way you evaluate it to another person, or like voting tasks that have different contributors and you compare it with others. You can correlate the task with other tasks in things like voting things. For example, if the distribution of all the people in certain area, so normally the people that deviate from this distribution will be neglected. So cheating detection mainly either by comparing it to a known task or going to another entity worker that know.
What you mean by cheaters, people who don't really do the efforts to do it well, who just kind of give them the answers?
Because some tasks in the crowdsourcing has says 5 cents if you did it, so I log in many times and do any output. Maybe from this output, maybe one will be good.
And there were robots doing that also.
Yeah.
So the robot, for example, putting anything, and that's it.
Yes.
Yes.
You
have to find it.
Yes.
It's a way to run
that is, and that is why if you
Try to robot that does
and if he answers without even thinking, if I give to him ground truth or well-known task, he will answer this in a wrong way, and it's a very simple task anyone can solve. So that means its quality is very little. So I will neglect this worker for time till he start to answer these tasks correctly. This one way that if automated or something like this, the simple task is in the middle, he will solve it wrong also. So because he will not focus on making the task in a good quality.
In the task design, you mentioned it was written in your slide, the compensation policy. Can you explain this?
Compensation policy.
What it is?
Yes. Actually, it's about incentives. People crowdsourcing in general built on incentives. So the successful model that makes people very excited to do something and expect something from to be output from the crowdsourcing. So we have two types of incentives. The first one is the social one, and this is domain. This is a very interesting domain in crowdsourcing called crowdsourcing crowdfunding. In this way, you collect money from people to make something to the society or something like this. So how you can motivate people to give money for this wise? One of the most promising application for this, it had different categories, and for all categories of interests for everyone, music and science and sports, anything. And you can select the categories that you are interested in, and you can launch campaigns that you need crowdfunding for this category so people support my project and make a detail for the project. The second point that people that register themselves that they are interested in a certain category, they find a notification that there is a new project near your home or near your house that will start, for example, you are interested in science and there is a new school or new library that will be built in near your house. If you want to contribute with effort or money or something like this. So what I mean, what we did here in the compensation, I searched for or I matched between what you really care about and what I will give to you. This is a social compensation. For example.
Yes. That's an interesting point because you distinguish between the users on the basis of some kind of implicit value system, that they will be more interested about things that go on in their neighborhood, or that are about topics they care about.
Yes.
And then you try to find the compensations that would match these people.
And it's a real-time program. You can see that each one pay a cent, you get notifications that till now we gathered $100 and something like this. So this real-time interaction makes people motivated more to participate, and this is also one of the aspects of your human interaction itself. The second way is the normal way of compensation, that you treat the crowdsourcing as a task or a normal work. For example, you can deliver this task and give $1 or something compensation for it.
But have you also thought about incentives in terms of reputation mechanisms, that people kind of get symbolic rewards of being considered better than the others?
Yes. And actually, this occurs in social. For example, in technical networks, you can say that I log into a certain technical network, and I am interested in a certain domain like embedded programming or certain Java programming, and I pick up the issues in this field because I am really curious about this field and solve these issues. So by solving them, I have more reputation in the system, and people making me as an SME saying matter expertise in this area. And also I have a social incentives. I see that I make a contribution to the field that I really love. That is why something like Stack Overflow have a successful model, because people that love, for example, Java, they get into it and find issues that they can solve, and they write solutions for it. And as long as you have a good matching between the source of service and you can make a source of service as a contributor itself, you can make a flourish for the crowdsourcing application itself.
But that's something I hadn't yet thought about. I don't know whether you had to look at my paper mobilization systems. But I kind of implicitly assume that you put the tasks in some kind of a system where people can easily find them, and that people would find them on the basis of their own interests. It's like in Wikipedia, you will typically edit a page about a topic that you are interested in, and you first search for that page, and then you see, yeah, what they write here, that's all very interesting, but they have forgotten to mention this, so you edit.
Yes.
But in this case, it's a little bit more like advertisers work now. They make profiles of what people are interested in, and then they send publicity that they think that kind of people would react to.
Yes.
Which is helpful, because indeed there may be tasks that you would like to participate in, but you don't know that they exist, so you're not going to search for them. So if the system can somehow guess that you may be interested in this task and warns you about it, that's an additional way to motivate. But you also have to distinguish, let's say, simply put, between two types of motives: altruistic and selfish. Altruistic is like, I think that's important, this domain is important, I would like to contribute to it. The selfish is, I would like others to appreciate me for what I have done, I would like to get something out of it, some kind of an authority, some kind of reputation, maybe I want to learn something that I could use later. The ideal system would have both. And by, of course, matching the domain to the person, it also, you will tend to have both types of intensity, because if the domain is in your domain of interest, you will be more inclined to help others in that domain. But it will also be a bit easier for you to get to develop some kind of an expertise or reputation in it.
Also about task granularity here, we can talk about it for yes.
That's also an interesting topic. Yeah, if you could give more examples about that.
Actually, the granularity in general, that for example, if I have a big task and I want to make it in small portions of tasks, the problem is that how you can make the overall task again combined together. Some platforms try to make this granularity to help others in this granularity in some predefined tasks. For example, it can make the task itself in a predefined, well-known examples that this task will be separated in 3 or 4 defined tasks, and so they can you can assign workers for them. But it's still research areas that how you can make an intelligent platform that could compromise between granularity and how to assign workers for, and the expected overall quality based on this granularity. and gradually it can make mathematical models for the best practice for the granularity based on the domain itself and based on the complexity of the task and based on the maturity of the worker themselves. So I think it will be promising research area to make something like automated tool that make people help people in assigning the tasks and allotting it into small portions based on a lot of historical data analysis. For example, if we made it very huge, it will make algebra to make an, for example, to decide which part of the task will be assigned alone. And one point also that helps in this way that you can make a mutual interaction between workers, because this not only make the overall task of the worker increase, but the worker can share the knowledge with other workers that have similar tasks to him. And some platforms enable this workers exchange this data and monitoring by monitors. And I think this factor also will make that the quality of overall is better, and you have to put it into your task design and assignment technique. For example, I can say that this task will be assigned for 2 workers, and they will cooperate and discuss with other workers in similar tasks like this. But still, this is a research point that still need a ground truth and need historical data to support people. And still now, most of task application need manuals that you can.
That's what I thought. It was done manually.
Yes, yes. But now, but I think it need to be programmatic point of view, because the system needs to study different factors, isolate the problem domain, and see for certain problem domain, study the factors like the complexity of the tasks and other things like this, and try to make an equation. For example, if we could map the overall combination between the problem domain and the complexity to something other domain like the function point or something like this. In the requirement we have function point means a small segment of requirement. We can measure the software with function points. We can say this screen has 10 function points. So why I need to make another domain to in order to unify the complexity in a middle layer like the function point layer. This function point layer will see, for example, tasks with 2 FPs will be alone. So we will make the task overall say 10 FP and spread it in 5 tasks with 2 FP. But again, it will have a lot of artificial to which 2 FPs that will be together from this 10 FP task. So automation.
Yeah, I know you have been working on this cohesion metrics for programs.
Yes.
In programs, the point is in how far can you modularize the program into relatively independent modules, and then you could give each module to one programmer. But generally, somebody will also have to know how all the modules fit together. So it's not trivial. Now, with programs, there exist some methodologies for them. But I was just thinking about another application domain. Let's say translation. You have a long book to translate.
Yes.
You could cut it up in chapters, you could cut it up in sentences, you could cut it up in paragraphs. These are very different granularities. Now, if you would cut it up in sentences, obviously the translation would not be very good because people wouldn't know the context.
Yes, you need to know the context to have an accurate translation.
So, another possibility would be that you cut it up in relatively small pieces, and then you give one person the task to go over all the pieces and agree about terminology, so that if some have to say the same thing in different ways, it's...
Yes, that is why we have to put the domain factor, the business domain factor in the automation process. I mean that allotting the task into several tasks in the translation business domain different than, for example, newspaper writing domain, articles writing domain. So it has to put the domain itself as a factor in the process of assigning the task and designing it.
What they were doing at one time is overloading. So doing a cut of the big task and then giving not only the same task to different people just to be sure of the results, but for example, you could have 2 sentences given to one translator, and then not the next two sentences, but decorated from one, you see?
Overlapping.
With overlapping parts. Because not only you need the context to be able to translate a sentence, but each person has his own style. So it would be a disaster. So with that, you ensure a little bit of a continuity in the same way of doing it.
It means a harmony overall.
You still need, well, at that time I was looking at it, they were still needing a human to recompose everything.
This
in
happens
the end, it might be less efficient. Actually. If the human needs to review everything and redo everything, it will be
At first sight, cutting up a translation, lots of small bits seems counterproductive.
You get voting people. For example, you have a crowdsource that does the control of what is coming out. So you only take a human to check what the crowdsourcing has voted as the best solution. So you have people solving the problem and people checking, evaluating the solvers. Yes. But as you say, you still have to make it efficient in cost.
And also you can select the workers with a certain correlated vision or background. This will reduce the deviation between them, for example. For example, we can see that it's similar to the boxes that have a single author and boxes that each chapter has his author. So if all the authors are from the same background, it will be better because you have in general same overview, but each one will take the chapter in his level. So this is what I mean. In order to have a better harmony, you can make, as you said, smaller exams or assignment for the workers to select the workers from the first that similar to their methodologies together. So you have their work overall has a better harmony together.
And can you talk us about the reputation system?
Okay. Actually, we use this part also, the reputation in general, in order to measure the incident itself. You have three domains to measure the quality of the incident. First domain is the maturity of the incident itself. So, for example, if I said that I see a crime, it's not an info. But if I say that I see a crime in this building, in this hour, someone doing this, and this is the exact data, the maturity increased. The other point is that who is telling this info. This is point we called about repetition. The repetition means that the systems can either make you are an anonymous person. So when you make a report the crime, no one would know that you will report. But the system knows that you reported the crime. You can either log in with a certain user, or you can don't log in and make it as anonymous. Anonymous will reduce the repetition level. But if I say this is my email, and we have a discrimination in the button that no one will harm you, your data will be anonymous. So I write my telephone number, I write my email, so we can track by this data this is the same user. So this user have a certain set of incidents. Both are not only verified, but also the maturity for each incident is a great maturity with the correct data and has a lot of images or something like this. So the overall repetition for the worker himself will be better. So when we make a new instance, say that the 10th incident maybe with better details than other one, but based on the combination of his repetition and the current incident details will make better trust for this incident than the other incident. The third domain that we talk about evaluating the incident itself or the work is the correlation with other incidents in a similar context, like in the similar place or something like this. The experience, both the domain of your past experience and your past education, combination of them sometimes called qualification based and context specific. The qualification based is something like certificates or something that knowledge that I prove that I have a certain knowledge in this area. And the other domain is the context specific, means that I have a proof that I had a hand-on experience in this task. Both the theoretical part and the practical part means that overall I am knowledgeable in this task.
I'm just thinking of a very paradox effect of this. Like if you imagine that a criminal starts to enter himself the crime that he does,
and he becomes a very trusted person.
He will have an excellent reputation because he is very good at it.
But this is related to the government, so they will go after him or her, the criminal. So they will remove him from the system.
No,
they may not find him, but the fact that his crimes are reported in details will make it easier for the government to establish patterns and like that to prevent.
He will not find the crime. I mean, he will make an incident, but in the future the incident simply approves the incident because it has an accurate data entry. But the other phase that we will strive to do is to close the cycle. I mean,
you can try to see if they report the incident, they are at the place of the incident because of the time. If I'm the criminal, I would do it when I'm at home, right? So
yes,
you see that they are reporting some crime that is a very long distance from there. There's something fishy.
Not necessarily. I'm interested in this starvation issue. So if I understood it well, the starvation issue is that the most difficult tasks, nobody volunteers to do them.
Yes.
And so you give them a higher priority. But how does the priority raise? Does the reward get higher?
Yes. Actually, you have two types. First type of task assignment itself is automated. Like mobile worker is a framework that automates the assignment of the task to the worker. And it make it initially I make the task as I design it, and I make say 10 points for the task, and the system make an combination between the initial time, the time domain, and the points of the task. So initially it will have the same value as the requester designed for it. And it will try to find anyone selected. If no one selected it, by certain time domain, it will increase its points, say by 1%, say to 11. So, but after a certain time, it will increase exponential way. So, in order to make the very difficult tasks not wait for a long time, so exponentially after a certain time, it will increase its points again and again. But
it could also be that at a certain point the requester says, well, I'm not willing to spend that much money on that task, maybe I'll just stop the task.
Yes, and actually it needs to be monitored and alarmed by the worker themselves to accept this approach of automation. But this is a trade-off because you make the computer itself monitors the starvation issue, because it monitors the computer makes 2 points. First, it monitors the time that the task is starvation, and the second point, it nominates the workers that are experts based on their history, as we discussed the history of the workers themselves, but also maybe the worker not interested in solving difficult tasks, as he can solve a smaller one and get more money. So that is why maybe if I give it higher money, it will be solved. That is why some automation.
And also the suggestion to solve it. Well, maybe first the task itself is not well defined.
Yes. Actually, this is when I start working with some of crowdsourcing platforms that make labels and badges and slogans for your campaigns. I found that the successful sites make a very deterministic definition of the task. They tell you, we will describe in detail, we will make this thing. With sample example for the budget that we design is this way. We will make this and this one. They define the quality of that, they will deliver in a very accurate way. So by this way, and also they insist that you write 10 lines or something like this to give what you are thinking about the slogan itself. For example, I need to make people, when they say this image, they feel was comfortable, they feel was something like this. So I write all things that I love to see in the image after it will be designed. All these things I write in detail, so when they say that, write in detail what you expect to see. So after this, by this way, the designer could make an accurate work. This is one of the major points that making a good quality design task itself and a very accurate definition of expected output will reduce hazards and also.
Yeah, related to this is one possibility would be to split the task. The task, if it's really difficult,
yes,
that's the classical way of solving problem, to split into smaller.
But depends, maybe the difficult task, if it's split, it becomes more difficult.
So yeah, it depends. Yeah, it depends. And another idea, and another idea would be to propose some collaboration.
Yes.
Maybe the task is too hard for one single individual.
And actually, using this paradigm like virtual organization. For example, since we are moving in like virtual reality, many things like we have cloud servers and cloud, we have also virtual organization. By this model in crowdsourcing, virtual organizations that I can make a whole newspaper without even have a place to the reporters come to me. I make crowdsourcing for people to give their feeds and write their reports, and gradually by voting system and by interaction I can select the best news. And also like in difficult tasks like programming and something like this, we can till now it's not so much in this field, but if it grows in fields like software engineering, and you can make virtual organization by this way, it will be very promising, especially for developing countries. For example, most expert people are seeking for some people that are very expert in mathematics and something like this, and they need to hire them in their organization, but they need them for a short task. They don't need for a long-term task, so they can, and also they need to assure how they are expert. So by making a crowdsourcing system that they solve some tasks in, say, in programming in long-term ways, they have a proven of evidence that they have a hands-on experience in this field, and they can use it in revenue in a complicated task. And in this way, you need also, as we said, the co-workers collaboration, because in the difficult and the big tasks like this, no one developer can work alone. You need a huge number of workers. But still, I think it doesn't. Till now, it's just a conceptual idea. It doesn't have a lot of successful models to make this this complex organization going on in a virtual way. But I think it will be less.
Well, maybe you should look at modern election organizations. Because I know some of these organizations that are using grassrooting, and they have this virtual organization that can go from 3 people to just keep the organization going to suddenly 3,000 people when there is an election. They have a very interesting structure to expand and collapse again.
Yes, but
they do, like, I know one company does that every 4 years for the presidential election.
Yes, but actually the election is a simple, so it's a simple task. But if you want to make virtual organization for example, to develop a very complex operating system or an embedded project that is really developed, say, for 2 years with 100 engineers working in it, how you can assign them and how you assure in this 1 year the 100 workers will not be the same. The 100 workers will, for example, I am an expert one and I will work a student, very expert student will work with 2 months in his vacation and will go away again. So how you can assure this flexibility in the complex and long-running organization? But if you could assure this, you will have tremendously flexible way of managing the human interaction. That is why in some lectures that they make a picture that we know that Pac-Man game. That Pac-Man game eats the planet itself. That means the software eats the planet, because now the software are training our mindset how to work well in order to make a better software. By this training, we will, and now he's trying to find tools to make us collaborate in a harmony virtual way to make his more mature. So this is like making virtuality in everything, not only virtuality in feeling like likes and dislikes in Facebook or something like that, not only virtuality, so, yeah, I need that everything turns to a piece of software, not only science and feeling, but also the physical organization are turning into piece of software. All organizations, universities and organizations, companies, everything will turn into a piece of software, and software overall manages our motivation and manages our mentality in order to orchestrate. It looks like to us like if we are small modules in the software overall, and you organize all these modules in order to produce a complex product for him. This is, I think, is going to happen in the next few years about.
Next 2 years is how many?
I think
5,
maybe
10?
earlier than this, but actually, because human invented something that is really promising for him, and this something actually is controlling, is taking over the control. That in a huge, I mean, anyways, maybe philosophy point of view, but virtuality is going to be something that occurs in many huge organizations. Actually, here we can talk about in the coordinators page, students can allocate the places that they will monitor building in them. Initially, this was very motivating for people because you can tell him that while you are going to the work or going back to your home, you will make an extra thing that really makes the society very useful to society. So he started looking in the streets while he was walking, and started to write down the description of certain streets that he found violation building and something like this.
Might be dangerous if he's taking photos of a building violation. He might be beaten up by the owner.
Actually, people here are engineers, student engineers, so they are very clever. They have been trained in the university to memorize the latitude and longitude of the yes. They make a lot of things. For example, they memorize the famous building with certain latitude and longitude, and they are expert to relatively say the distance, say 100 meters between this, so they can expect the latitude and longitude for the violation building, something like this. They are very expert in this. And another example that we monitored in the Batak, but not initiated by us, initiated by other campaign, with very good example that car stolen. A lot of cars were stolen after the revolution, so another team for stealing cars make an initiative, very strange initiatives. His car was stolen, and after he reported this crime, nothing occurred. So after that, he was noticing that some cars in the streets are left for many days with no one asking for them. So he thought that these cars may be stolen. So he went to the policeman department of the cars stolen and said to them, "Did you find any cars?" They said no. So, but they said that we have another cars, and he looked to these cars in the yard of and found most of this like the cars he's not in the streets has a lot of dust on them, like this, something like this. So he and all his colleges started to make initiatives that everyone, when he was walking in the street, if he notices that certain cars are archaic or left for a long time, he pick up a phone and call him and tell him with the specs and the telephone number, the number of the car. Even and actually they reported about 100 incidents, and about 40% of them were really stolen cars. They can't, because criminals lean on that no one will do an action for this, no one will notice that this car that is left for this long days will be really stolen. And actually, we take all these incidents in our system and we try to make a campaign for this. But the difference that we don't have a major reporters like this case. But I think with good media to focus on something like this, because they have a statistical research that most of stolen cars are either make a crime with it, or he left it in the street, and each time he pick up the motor or something like this from the car and leave the car as it is. He doesn't pay to gather all the stolen cars in a certain place. This is a percentage, so I don't know the concrete result. But for example, if it is 30%, you can discover 30%. If you have 100,000 stolen cars, you have a huge number of stolen cars actually. So if you have 100,000 stolen cars, you will return about 30,000 of stolen cars. So it's a major. And you doesn't need anything except when you are walking in your street, you just memorize, and we make a campaign that how you memorize this car is stolen. Certain characteristic. Yes. For example, people started to give pictures for cars left for years, and no one actually can leave his car for years unless he is in travel. And this is a frequent case, but the frequent case that this will be a stolen car.
I think that's a very good example of a crowdsourcing application, because the police cannot go to all the streets to look at all the cars. On the other hand, people who always pass through the same street, they will notice that a certain car has been there for months or years. And for them it's pretty easy if you have something like Ushahidi to enter it, and then you just need to match the one database of the abandoned cars with the other database of the stolen cars, and you will find matches.
Yes. And this is why we was talking about human sensors, because in this type of crowdsourcing, they mimic the human as a human sensor. So by this human sensor, you save a lot of cameras and a lot of costs to monitor this type of crimes. But the other point that in order also Professor Ayman went to the mayor of Fayoum and saw him as a secretary to this initiative, and they are very interested in it because it saves a lot of time for engineers to walk around all the streets to get the details for the building violation. Instead of this, you have a report, and you also, the mayor was excited because he also can track the quality of service. The time between the student or the reporter take an incident, report an incident, and the time it was fixed. But he didn't develop this part yet. It was intended to make a life cycle for the incident. The incident, we started with managing the reporter allocation in the coordinator page, saying the reporter makes the incident and we evaluate it according to this criteria, and then it appears to the site. But the other life cycle of the incident itself, after it appears to the site, the government should assign certain engineer or something to solve this issue, or a policeman to solve this, and we can assure the quality of service, the time difference between I reported the incident and it was really fixed. But it's later phases, but it's a very, very good example to assure a quality of service for something like this. Also here in evaluation mechanism in North Meta, we made it generic. For example, our vision was to make evaluation crowdsourcing application. In general, you can evaluate anyone for his any action. For example, I can say that I'm a professor. I see that my duty to do X, Y, Z, and I think that in the next year I will do this task. This task is my vision. I will enhance this and I will do this. And you can tackle the progress and by different ways, by either numerical approach and satisfaction. Satisfaction is just average way to measure either numerical approach is correlated to what is really happening in the reality or not. Anyone want to talk about this?
I'm not sure I understood the electron cloud idea. You mean that there is a kind of a probability distribution that somebody would have the right skill for a particular task?
Yes. Actually, there is called an uncertainty principle. Uncertainty principle that I can't assure the time and the location of the electron. Either I assure the time, so the location will be a cloud or distribution, or I assure that the location and the time will be a probability. I assure both of them. And this occurs in reality in our life. For example, I can't assure that you will be happy in a certain time, but I can assure that if a certain event occurred, probably will be happy. And the other thing, so if I focus the certain domain, I will the other domain, the happiness will be a cloud. And if I focus the happiness, the time domain will be a probability. For example, if I think that you must be happy, probably if certain event occurs to you. And if I fix it at a time, so when you get up, so the probability of happiness is a distribution. But I can't assure both of them together. So, unless it's realistic, and in small cases I can assure both the combination. But this is here in the cloud means that in electron clouds that points with high density in the screens, that the electron probability of existence in this area is much higher than the other area. So the electron spend time here. That is why I mean that I spend my time in this scale, so that this domain is, because there is no super actor in the global brains. There is no super actor.
Well, in a sense, you may not be aware, but implicitly in the model of the skill vector is that the agent will select the challenge in part based on the similarity with the skill vector, but the similarity with the skill vector is actually the vector product, the scalar product of the two vectors. And the scalar product is exactly what you use in quantum mechanics to calculate the probability of getting a certain result. You have a property that you measure, and the property that you measure, the eigenvector of the operator that you measure is the possible results. And then what you do is you project the state onto the eigenvectors, and the size of the projection is the probability that you would get that result. So in a sense, what we are doing here is the same, is something similar, because we are multiplying the skill vector with the challenge vector. It's as if we're projecting the challenge onto the skill vector, and the projection says kind of the probability that this will be a good challenge for that vector, for that agent. So it's maybe more similar to the electron cloud than you thought. It's not exactly the same, but it's a similar reasoning.
This is the recommendation.
But I want to ask regarding this process enhancement. How do you connect this to the child prop? Because as I understood, this is general how do you think about the process?
Child prop itself will be separated in different layers, but we will talk about the simulation running layer itself in the child prop itself.
But I didn't really understand. Does it mean that it implies simulation of the child prop, which is itself a simulation, simulation of the simulation?
No. Run simulation is running the child prop itself, but it will be but child prop running is a simulation for the systems that I digested.
Okay.
So why it is a simulation? Because I get the bust variables from the system, and I get the key identified feature for this variable, and I run a simulation, and I can use this to make a forecasting for the people behavior in a certain context.
Because you look at the GBI model at the moment, not really as a model of the global brain, but as a modeling environment for a specific kind of problem that is held by a particular business.
Yes, and that is why I redirected to the decision-making system. I mean that I can say that by tracking the agent behavior and the social mathematical interactions, I can forecast that for a long time you have a certain aspect that is decaying by time. For example, I can measure that our wave interaction is making the certain domains, the social interaction, for example, is decaying. And I can make it to the decision-making system and say after 1 year it will have impact on certain other factors like crimes or something like this, so or divorcing or something like this. So this will be again routed into the same system by making decisions and monitoring again is pick up progress in the system or not.
So, but so you're interpreting the global brain model as a kind of problem-solving platform for specific problems of specific groups or organizations, which is a possible application, but which is not, let's say, our main focus at the moment.
Yes, but it will be promising as marketing, well, marketing for different, not only organizations, but also not only government, but any organizations that can tackle data mining for this data and making proper decisions to either you can say this iterative model, either people as an active or a passive system. For example, that I can change the mindset, I can control the mindset, so I can select those, so they will select in a certain moment what I want them to select. Or the other way is that I am a passive system, they select things and I just advise them to select things better. So, but all in all is the same mathematical cycle model. For example, if I want people to select a certain person, and I know that people select, for example, security. So if I correlated this person with security, I make that people select the person. This is the bipartitude modularity in the graph there. So by this way, you can make analytics to digest what people select and correlate this selection with another external nodes that you need them to select, and by this way you can make them select this node. Or the opposite way, you just monitoring what they select, and we say that we can enhance their selection by making them focus on other domains that they are really not focusing. But all in all, you just need to digest. This is the first layer. You need to digest the model, and then know what people really think in order to interact with this.
So it's to simulate the effect of policymaking. So you think,
yes,
okay,
yes.
What if I do this? Will it work?
Yes.
You put it there on the parameters, you run your simulation, you do the analysis and see what's the
result. Yes, exactly what I mean.
Was it good or not? No, it has the counter effect. I change it.
And that is in the opposite direction. If I want to make this decision and people be happy with it, how I can make people happy with the decisions that I will make? If I correlated it in a bipartitude with another thing that is really they happy with it. This correlation code we have in the graph theory that we have in the graph like nodes like say these nodes, for example the actors, and this actor A and B from category X, and this is actors C and D from certain category Y. This is the partitude 1, and the second partitude are not the actors, but like for example the movies, and they have. Okay.
I've seen these examples.
Yes.
Let's continue.
And movie one, say movie M1 and M2, for example, in category of action movie, and can correlate this one to this one, for example, and we have also movie M3 and M4 for certain category and correlate this with this. This bipartitude means that the graph have in general two kinds of domains of nodes. First nodes say the actor domain, and second nodes the movies domain, and how I correlate them. We can use this in politics. How we can use in politics? I can say that people here, for example, love certain area. We can spell it security or security area or something like this. And people in this love certain area. Why? So if I made a new campaign And my guy in this campaign, working in the security, motivate people with security, I expect that my guy will get all actors in this area, in segment X. And the other guy that works was in not only security, we can say is, for example, economic factor, economy, or something like this. And say, for example, this is 70% of people, and these are 30% of people. So the party that has one representative from the security domain will have 70% of the voting. And this is used in bipartitude. You can correlate the domain. In general, it's used in many things. For example, you can expect it naturally. People that like certain pages because these pages express their idea. And these pages that express their idea makes them in a certain category. So you can collect all the ideas in a certain category and make this segment A and segment B. And you can say correlate the bipartitude of this segment to the agents themselves, people. So you can say that if I'm tackling security and economy or something like this, all the people that are correlated, like pages A, B, and C in the Facebook, are curious with this area. So I'm assured if I make my election, I will get 70% of the people.
Yeah.
This is only under one final constraint, that the distribution of Facebook users are highly correlated to the normal user, and this is actually not the truth.
No, but it's not always true that.
Yes, actually, bipartitude is a very simple model. But actually, the reality is in domains of partitudes. But you want to aggregate all the end layers into finally how I correlate between the first layer and the second layer, the final layer. And
but the correlation may not be perfect, that some clusters here will link to several clusters there, and vice versa.
And there is a result of algebra for this bipartitude modularity, but we just made an algebra for this because it runs on a huge segment of users. I mean that you are analyzing billions of nodes, and the billions of nodes may be 1 billion of users, of Facebook user, and say 10 billions of pages and other things. So when you want to correlate these billions of nodes together, so it can be manual. So they make this mathematical model like this. But also, a second interesting point is that there is not much correlation between the Facebook users distribution and the normal user distribution. For example, I say that assume that this is the segment that most of the people will be in this area. Say 30% here and 70% here. But this is the Facebook segment, and actually the natural segment will totally not correlated with Facebook segment. It can be any other distribution. And what makes the natural life, if you study it and put it in a graph like this, you can control it also. For example, if he says that the natural people that not using Facebook are biased by, for example, certain piece of info like the media, channel movies or the media, etc. So if I control the media, make a control variable to draw again the bipartitude. But actually, under certain constraints that I have to need to understand the model, the phenomena that I model. So I can't unleash that all the users are Facebook users. Actually, this distribution doesn't reflect the reality.
So it's a kind of a model how to control the society.
Yes, I said both approaches. Either you can have a good point of view to digest people behavior, or you can say that a superior entity and I want to control others. But
I think it is a moral problem.
Yes.
It is more thinking on letting the simulation live by itself and flourish. And self-evolve, and you are telling we can put parameters there and then control them. That's just...
Actually, it uses to some extent. For example, in some campaigns, you need to market for your product to make people convinced that it's very important. Actually, it's not important, but you are making fictitious needs to what you really want to market, and this is the cycle. And how you target this, in order to target this type of attitude, we have a segment of four categories of people. People like motion, and people like emotions, or people like analytics, and we have 4 category segments. So I can target the campaign for example, I want to make advertise for a car, and say it will tell you that for people that have a lot of emotions, that this car will make you go out with your family, and I'm tackling the emotion part. And if you are a practical person, I tell you that it's very fast car and it doesn't consume a lot of fuel or something like this. By making this way, I try to correlate the bipartitude model in general. But again, it's sometimes it's as you said, it's philosophy point of view. Sometimes I use it for a good reason, and sometimes I can use it for a bad reason. But
I haven't yet heard you speak about the global brain as such, the idea that all these different systems would kind of merge into one giant system that would make collaboration worldwide much more efficient. What's your attitude towards that? Because this global brain system would kind of a little bit start to play the role of the gods that you were describing in your previous talks, kind of steering people towards the best things for them to do and steer them away from the things that are not so good for them to do.
Yes. Actually, promising to think in it in that way and model it in that way, because it also will get us have a lot of metaphors in understanding a lot of phenomena that occurs around us. But in that way, you need to analyze not only the social behaviors in a small entity like social network, but the social behavior in a huge number of domains. How students interact in the class, and how people interact in the life, and how this overall reflect their properties of spiritual and mental evolution. And it will be very useful also in order to make model for this, and to in a best way to make a best practice for advising people how to enhance the way of interaction together in real type examples, in a big major scale like the global overall.
Do you think it's likely that an integrated system will develop at a world level like this?
I don't get the question.
Do you think it's likely that something like a global brain will emerge out of all these independent systems?
I think, again, we are talking about modeling. I can see electrons that spin around an atom as an ellipse. It's a very simple model, but I don't need more complexity than this, because I just need to know the spaces and times or something like this. So the reality is very, very complex. Mm-hmm. So I will not model the reality. No one can model the reality. The modeling means that you pick up certain aspect from the reality and put it in your system or in an equation. So what I mean that global brain is sufficient until it answers certain simple questions that we need and to answer in our society. In that way, it can be modeled and measured, but it can't. It can't measure a lot of things and a complex situation. Something like that. We need it in a global point of view to answer deterministic and set questions. In this way, you can model it. But in order to real time analyze a deep interaction all people and something like this, I think it will be very difficult to make a mathematical model for this, and number of domains.
No, I agree. No, I'm not speaking about a mathematical model now. I'm speaking, but probably you have just said a mathematical modeling paper, and not of the other papers about the global brain. The global brain is kind of a metaphor to make us understand what our information society is evolving towards. Instead of a fragmentation of different countries and different organizations, that in the end, all the individuals would kind of directly interconnect via this global network. That there wouldn't be these kind of subdivisions anymore, like countries or religions or groups, but that everybody would be an individual within this kind of encompassing network that would make all the individuals collaborate in the most synergetic possible way. That's kind of the idea, the metaphor that guides the global brain vision.
Yes, I think it's useful also to model it in this way, and again, it will be feasible to be done, and when if we restrict it, say, again, on a certain level of applicability and certain level of questions that we need to answer by this global modeling. I mean that I can measure in this way the collaboration from all the 5 billion or 6 billion entities on the planet, but I need to measure certain aspects of the collaboration itself. That's why it's feasible, but it will not answer. It will answer deterministic, exact questions. I mean this. You have to determine certain aspects.
Well, I mean, certain questions, you will never get a deterministic answer for.
Not a deterministic answer, but I mean limited number of questions.
Yeah. Yeah, you can't have a model that answers all questions, of course.
Yes, that is why you can't model the reality.
That's why I would call it a paradigm or a metaphor or a vision rather than a model. The model is one aspect of it. Some aspects of it you can model mathematically, yes. Other aspects are more kind of philosophical or sociological or whatever you call it, but it's kind of a vision of how human society would evolve. So you don't have any particular thoughts about that?
No, actually, I'm in research in this at the moment, the tools in this area.
Any further questions? Then I think we will stop here. Thank you again.